Here we're going to look at question 10 of the ENGAA 2018 paper. In this question we have an electric car with a motor which we're told has a potential difference across it of 400 volts and a current through it of 1250 amps. We're then told that the car accelerates for 4 seconds. And finally, the efficiency of the whole system, that is the efficiency of the car, is 45%. Finally, we're asked the question, what is the kinetic energy of the car after 4 seconds? Now this question might initially seem quite tricky, since the answer we're asked for is a kinetic energy, yet none of the information we're given seems to directly relate to an energy. To help us try and solve this, let's think about which equations we could use with the information we're given. So, the motor, we're told, has a voltage across it of 400 volts and a current through it of 1250 amps. Now, whenever you see these two together, this should generally try and spring to mind the formula that the power of an appliance is equal to the voltage across it multiplied by the current through it. Now, especially with motors, this is an equation which comes up quite often, especially whenever you're talking about energy or power. We then also know that the energy supplied by an appliance is the power of the appliance multiplied by the time period we're looking at the energy being supplied in. Now this is useful because we're told the time that the car accelerates in, and we also could find out the power of the motor. Therefore, those together would give us the total energy used by the car in our time period. So, first, let's try and find the power of the motor, which, as we said before, we do by multiplying the voltage across it by the current through it. So, this is our 400 volts multiplied by our 1250 amps, giving, after a small bit of calculation, a value of 500,000 watts. To calculate the energy which the motor produces in our 4 seconds of acceleration, then we can go ahead and multiply the value of power, which I've just changed here to standard form, by the time period, our 4 seconds. This then gives us a total energy produced by the motor of 2 times 10 to the 6 joules. However, the question is asking us for the kinetic energy of the car after 4 seconds, not the total energy. Now, the difference is that we're told that the energy has an efficiency, or the motor has an efficiency, sorry. So what this efficiency means is that 45% of all of the energy produced by the motor is converted into kinetic energy. So, to try and find the total kinetic energy, we're going to take our total energy, 2 times 10 to the 6 joules, and multiply it by our efficiency factor. So, here we are, and then with some small calculations, we find out that this is 0.9 times 10 to the 6 joules, which we can change into standard form as 9 times 10 to the 5 joules. This corresponds to answer C.